Yes. Okay, so one angle is 90 degree. Okay, that's good. It's given, right? And so if I just name it, right, angle 1 and angle 2, let me call it this one. Let me just erase it. So let me call this angle is angle 1 and this angle is angle 2, the inside one. So the first thing is angle 1 is equal to angle 2. Sorry, in triangles. Okay, let me write roughly. So angle 1 is equal to angle 2, first thing. Then
A QP are common.
sorry, say again. Okay, some issue I think with your network. See, Jaslyn, first of all,
Ma'am, can you hear me?
I'm not able to hear. Can you just type? Your voice is actually breaking. Okay, see here, angle 1 is equal to angle 2. That is one thing we can see, right? Now, we have to make use of this thing. I always say make use of whatever is given to you. So ABCD is a parallelogram, right? That means opposite sides are parallel to each other. So if this side CD is parallel to this side AB and this is a transversal which is cutting. So that means this acute angle is equal to this acute angle, isn't it? These are alternate interior angles. So that means this angle will be equal to this angle, right? If I call it this angle 3 and I call it this angle 4. Is that clear?
Yes,
Okay.
ma'am.
Okay. And again, it's a parallelogram. So opposite sides are equal, isn't it? So your AB side will be equal to CD because it's a parallelogram. Opposite sides are equal.
Yes, ma'am.
Okay. So three things I have got here. So in triangle APB and triangle CQD. So now I have angle 1 is equal to angle 2, 90 degree each given. Then I have okay, you can do, or here itself you can do. Now since ABCD is a parallelogram, so this implies that CD is parallel to AB, right? And this implies angle 3 is equal to angle 4, which are called alternate interior angles. So two things I have got. And the third one is you can mark like this also. Like this is the first thing you have got. This is the second thing you have got. And the third is also ABCD is a parallelogram. So you can say that AB is equal to CD of a parallelogram are equal. So this is the third thing you have got. So from 1, 2, and 3, from 1, 2, and 3, right? Now, which criteria? You have two angle and one side. So, AAS criteria. By AAS criteria, triangle A, what was that? Triangle APB is congruent to triangle CQD, right? So this is first part we have proved. Now second part, now because the triangles are congruent, so by CPCT we can say, so since triangle APB is congruent to triangle CQD, So by CPCT, we can say that AP is equal to CQ. You know what is AP and CQ? So this was the diagonal. So this is AP and this is CQ, right?
Yes, ma'am.
So this is by CPCT. This question was easy. Now let's do question number 11. Okay, let us understand the question first. Okay, Jaslyn, you have exam on Monday of 40 marks. Which chapters are coming?
There is statistics,
Hmm.
triangles, lines and angles,
Hmm.
and introduction to Euclid geometry.
Coordinate geometry. Okay.
Euclid geometry, not coordinate geometry.
Okay, fine. So are you confident in those chapters?
Yes, ma'am. But lines and angles.
Okay, if you have any doubt that you can ask.
Okay, ma'am. That's it.
Sorry, Jaslyn. Okay, so you can type if you want to say something. I think from your side, when you try to speak now, I'm not able to hear the words properly. So I don't understand. Okay, now see here. So I think some concepts of lines and angles are also included here. So I'll go through the chapter again and see if I have any doubt. Okay, then on Saturday you can ask. Or I think on Saturday I'll try to have a revision of lines and angles. Let's see if I get time. Okay. Now see here. Question number 11. So in triangle ABC, now look at the triangle ABC, that means this triangle, right? And DEF, that means this triangle. AB is equal to DE. So AB, that means this side is equal to this side, DE. Okay. AB is parallel to DE, right? BC is equal to EF. So this BC is equal to EF. And BC is also parallel to EF. Okay. Vertices A, B, C are joined to vertices, right? As you can see, AD are joined, PE are joined, CF are joined. Show that quadrilateral ABED is a parallelogram. Can you see ABDE in the figure?
Yes, ma'am.
Okay. Let us note down, first of all, whatever is given to us. Right. And here I can write that AB is parallel to DC, also given.
Ma'am,
And
you sharing screen.
D DE, sorry. Yeah.
Ma'am, I can't see your screen. You stop sharing.
Okay. Just 1 minute. Yeah. Is it visible now?
Yes, ma'am.
Okay. This much is given. And then you have to prove first thing. So let us try to prove the first one, that ABED is a parallelogram that you have to prove. So what is the property of a parallelogram? First of all, tell me. So there are many theorems we studied. So opposite sides are equal, opposite sides are parallel, right? And there was one more, that if only one pair of opposite side is equal and parallel, then also it's a parallelogram. Is that clear?
Yes, ma'am.
Now see, look at this parallelogram. Look at it like this. Let's say this is your parallelogram, A, B, and D, E, right? A, B, E, D, right? Now it is already given that one of the side, that means AB is equal to DE, right? Okay, and it is also given that this side AB is parallel to DE. Both the things are given. So this side is equal and this side is parallel. So we can use the theorem. So this implies that one pair of opposite sides are equal and parallel to each other. And therefore we can say that ABED is a parallelogram. So there are two things, okay, remember, they have to be equal also, they have to be parallel also. So if only one pair of opposite side is satisfying these two conditions, then also we can say it's a parallelogram. So we don't need to think about the other pair of sides, only one pair is enough. Clear?
Yes, ma'am.
Okay. Now similarly, now look at the second part. Now BEFC is a parallelogram. Now where is BEFC? BEFC, okay, the bottom one, right? So the bottom one, the base of this parallelogram. This is BCEF. Just draw it like this. Clear?
Yes, ma'am.
Now what is given? Let's see. BC is equal to EF and BC is also parallel to EF. Again, same theorem we will use. Right? So in quadrilateral, what is BEFC? So BC is equal to EF, right? And BC is also parallel to EF. Both these two things are already given to us. So again, we can say that one pair. So here one pair of opposite sides are, so they are equal and they are parallel to each other. And therefore we can say that BEFC is a parallelogram. Understand?
Yes, ma'am.
Okay. Now third part. Right. So in the third part, you have to prove this, that AD is parallel to CF and AD is equal to CF. This you have to show. Now, where is AD? So that means this side, right? AD, and this side is CF, the back side of this. Understand? So it is looking like this in the figure. This is AD F, and C, right? So you have to take this side and this side. You have to show that they are equal and parallel. So how will you do it? Right, in the first part, what we did, now see here, in part 1, what we proved? So we proved that A, B, E, D is a parallelogram. Is that clear?
Yes, ma'am.
Already proved. Okay. Now, because it is a parallelogram, so when we were proving this parallelogram, so we considered this side and this side. Now, because we have proved that it is a parallelogram, so that means the opposite side is also equal. The other pair of side is also equal because it's a parallelogram, right? So we can say that the other side, which is AD, is equal to BE. From this, we can say from part 1 itself, right? And also we can say that AD is parallel to BE. Why? Because opposite sides of parallelogram are equal and parallel, isn't it? Yes, Jaslyn?
Yes, ma'am.
Okay. Now, in part 2, we proved that this is a parallelogram, the base. So in part second, we proved that BEFC is a parallelogram, right? We have proved it. Now, because we have proved it, so that means the other pair of side is also equal and parallel. So we can say that BE is equal to CF and BE is parallel to CF. Again, the same thing, that opposite sides of parallelogram are equal and parallel. One, and this is your result number 2. Now you just compare both the results. So from 1 and 2. So you can see AD is equal to BE and BE is equal to CF. So means AD is equal to CF, right? Both are
Yeah,
equal to BE.
yeah.
Okay. And now see, AD is parallel to BE and BE is parallel to CF, right? So we can say that AD is also parallel to CF, isn't it?
Yes, ma'am.
And yeah, this we were supposed to prove. See, Jaslyn, now try to understand one thing here. If you remember lines and angles, because you're also having an exam. So if try to understand, see here, if AD is parallel to BE, right? And I'm writing that BE is parallel to CF. Is that clear? So
Ye-
how can I say that AD is parallel to CF? See, it's not algebra. So I cannot say that, okay, both are looking parallel. It is parallel to BE. This is parallel to BE. So this is parallel. No, it is because of a theorem. Understand? I think
Yes,
I
ma'am.
also told you in that chapter. So it is actually because of a theorem. What is the theorem? For example, you have three lines, right? L, M, N, right? So I'm saying that the line L is parallel to M. Clear? And I'm saying that line L is parallel to N. So from here I can say that, so I mean the theorem is that if two lines are parallel to the same line, understand?
Yes, ma'am.
So M is also parallel to L and N is also parallel to L. So if they are parallel to a same line, so it implies that they are parallel to each other also. Understand?
Yes, ma'am.
So same theorem is actually used here, that AD is all parallel to BE and CF is also parallel to BE. So that means they are parallel in itself. So we have proved part number 3. So let's now do part, I think you have written, I hope.
Yes, ma'am.
Right, now part number 4. So in this part, you have to show now to prove that quadrilateral ACFD is a parallelogram. So this is the continuation of what we just did, right? So in part, the previous part, third, what we have proved? So we have just proved that AD is equal to CF, right? That means
Yes.
this side is equal to this side CF. And we have proved that AD is parallel to CF. So again, the theorem we can use that we can see here that one pair of opposite sides are equal and parallel. So we can say it's a parallelogram, right? So this implies that ACFD is a parallelogram. Okay, now in the fifth part, you have to prove that AC is equal to DF. Now, how can you say that? Again, the same thing we can say now, because it is a parallelogram, that means the opposite sides are equal. Yes.
Yes.
So we have just proved, since ACFD is a parallelogram, we have already proved just now. So that means AC is equal to DF. Why? Opposite sides of a parallelogram are equal. Right? Well, now the next part of this question. So in part 6th, now you have to show, to prove that triangle ABC is congruent to triangle DEF, right? So that means this triangle ABC is congruent to this DEF. Understand? Okay. So here, look at the three sides of the triangle. Two sides are already given to be equal. AB is equal to DE. This was already given to us, right? AB is equal to DE. This was given. Okay. And another BC is equal to EF. This was also given. Understand? This side and this side. Okay. And we have just proved that AC is equal to DF. In previous part, we have proved. So all the three sides of the triangle are equal. So by SSS criteria, we can say that triangle ABC is congruent to triangle DEF. Okay, Jaslyn, now question number 12. Now see, ABCD is a trapezium in which AB is parallel to CD. So it is given that AB is parallel to CD. Okay, and AD is equal to BC. This is also given that AD is equal to BC. Show that angle A is equal to angle B. So angle B here means this side, this angle they are talking. Understand?
Yes, sir.
Okay. See why angle B is only this and not the complete one? Because actually trapezium is this, right? This is your trapezium, A, B, C, D. And this, after this, they have done a construction. So this part is actually a construction. So that means angle B is only this much. Understand? Okay. Right. And you have to show this basically. And also you have to show that angle C is equal to angle D. That means this angle is equal to this angle. And triangle ABC. Where is ABC? Okay, so that means we have to draw it later on, is congruent to BAD. So, okay, let's do the first part first of all. So to prove, you can write, I'm just doing the proof of part 1. So angle A and angle B you have to show equal. Okay, so before that, let us do one construction that you will write. Construction is this: extend the side AB, right? So we have extended this side AB like this and draw a line through C. So through C, we have drawn a line which intersect it at E, right? And also this line is parallel to DA. Understand? So this CE is parallel to DA. We have drawn it like this. So through C, we have drawn a parallel line to DA, and this line will intersect here at E. Intersecting AB produced at E. Is that clear?
Yes, ma'am.
Okay. So now think of it like this. Now this figure, you can think of it like this as a parallelogram. Just, I mean, rough I'm drawing, right? So basically, in part 1, you have to show angle A is equal to angle B. Okay, B you have to show. Anyway, first of all, let us prove that it is a parallelogram, this figure. So one pair of side I need parallel and equal. Understand?
Yes.
Okay, so here AD is parallel to CE. Why? From construction, right? We have constructed CE such that. Understand? So CE is constructed like that it is parallel to AD. So from construction, AD side is parallel to CE side. Okay. And okay, it is already given that AB is parallel to CD, right? So see, if this much part is parallel to this line, so if I extend this part, so this complete will also be parallel to this complete, isn't it? I'm just expanding it, right? So I can say that your complete AE is parallel to CD. Why? I mean, since AB is parallel to CD. Understand? Only AB was parallel to CD, and I have just extended this. So that means this AE is also parallel to CD. Clear? So in this parallelogram, if this is your parallelogram, so we can see that this side is parallel to this side and this side is parallel to this side. I mean, in this quadrilateral. So we can say it's a parallelogram because the opposite sides are parallel. Understand?
Yes, ma'am.
So in quadrilateral, A, E, C, D, both pair of opposite sides are parallel. So therefore we can say it's a parallelogram. So therefore A, E, C, D is a parallelogram. Understand?
Yes.
Okay. Now it's a parallelogram. So the figure is like this, if you can see. So this is AE and CD. Now it is because it's a parallelogram. So can I say that ED is equal to CE? That also I can say.
Yes, ma'am.
Now because opposite sides are equal also, right? In a parallelogram.
Yes.
So opposite sides are equal in a parallelogram. So that is why AD is equal to CE, right? But in the question it was given that AD is equal to BC. This was given to us. So what does it imply? So it implies that CE is equal to BC, isn't it? From these two. Both are equal to AD, so that means CE is equal to BC. Is that clear? Right.
Yes.
Now you look at this triangle. So this is the triangle BEC. I mean, you can draw a short, small triangle so that you remember what we are doing basically. So separately, you can show this triangle. So this is BEC. Now in this triangle, this side BC is equal to this side. So that means this angle is going to be equal to this angle, right? If I call this angle 3 and I call this angle 4. Is that clear? So in your figure, this is 3 and this is 4. Understand? So we can say now because sides are equal, so angle 3 is equal to angle 4. Why? Angles opposite to equal sides are in a isosceles triangle. Right?
Yes.
Okay. Now okay, now one by one we look at this figure again. So I'm just drawing it again because I'm not able to see it. So I think it's looking like this, right? So this was your A, and then here you have your B and E, C, D. Is that right? Okay. Now one by one, look at it like this. First thing that, okay, I'm drawing two columns. So one time I'm looking that AD is parallel to CE, right? Can you see that? AD is parallel to CE.
Yes, ma'am.
Okay. Now this side is parallel to this side, CE. So just think of it like this. And AE is a transversal. Is that clear? AE is basically a transversal. So now if you have two parallel lines and then there is a transversal, so that means sum of this angle and this angle is 180 degree, that you know. In chapter lines and angles also it was there, right? That sum of interior angle is supplementary. Remember?
Yes, ma'am.
So I was calling it angle 3. Yeah, this was 3, right? Yeah, this was 3. And this was 4. So I can say that angle A plus angle 3 is 180 degree. Understand? Why I can say that co-interior angles are supplementary. That is why. So from here I get the value of angle A, which is 180 degree minus angle 3. Remember? Okay, anyway, just give it some name. Let me call it my equation number uh, 3, 4, whatever it is. Call it 4. I think 1, 2, 3 was earlier there in the question. Any name you can give. It's just a name, right? Call it 4. Okay. Now you come to this part. Now see here. I am saying that AE is a line. CAE, right? It is a line. So that means this angle and plus 4 should be equal to 180 degree. Just call it something. Let me call it 5. So angle 5 plus angle 4 and yeah, it is equal to 180 degree. Why? Because it's a linear pair. Clear?
Yes, ma'am.
Okay, so angle 5 will be 180 degree minus angle 4. Remember? I mean, is that okay?
Yes, ma'am.
Okay. Now, there was one more thing. Let me call this result as my equation number 3. Clear? So in place of angle 4, now I can write angle 3. So angle 5 will be 180 degree minus angle 3. Now you can call it equation number 5. Right? Because we have already shown that angle 3 is equal to angle 4, so that I have used here. In the bracket, you can say from third. So third result you are using. Now you compare your result 4 and 5. From 4 and 5. And that means this and this. What can you see? RHS 180 minus angle 3, 180 minus angle 3. Clear? So can I say that angle A is equal to angle 5 from 4th and 5th?
Yes.
Okay, and what is angle 5? It's angle B basically. So angle A is equal to angle B. Proved. Well, let's do the second part also of this question. So again, I'm drawing the figure here. So now it is like this: A, B, E, and C and D. And I was giving some names. So this was 3, 4, and this was 5. So what you have to prove now? To prove that angle C is equal to angle D this time. So that means this much angle is equal to this much angle. Understand? Mm. Okay, now I'm saying that for AB parallel to CD. Can you see AB parallel to CD? See, there are two things here. AB is parallel to CD. Fine, Jaslyn? Now you have two transversal. One transversal is this, another transversal is this. Is that clear?
Yes, ma'am.
So one by one we are taking. So for AB parallel to CD. Okay,
Okay.
you can do a comparison also if you want. Again, for AB parallel to CD, but this time I'm taking and sorry, AD is transversal. Understand?
Yes, ma'am.
Okay, and here I'll take and BC is transversal. So what will happen? So both cases I'm considering. Now if AD is transversal, so this angle and plus this angle is equal to 180 degree. Why?
Supplementary.
Yes, you will write co-interior angles are supplementary. Okay, so that's the reason, right? I'm just calling it as some equation number 1. Right. Now again here if I use the same thing, so BC is transversal. So I can say that angle See, if you're confused in angle B, you can write 5. No issue, right? Angle 5 and plus angle C. Understand? C
Yes.
also, if you are confused, you can give it some name. Let me give it 6. So call it angle 5 plus angle 6. Is that clear?
Yes, ma'am.
Okay. Again, this is equal to 180 degree. So from here, you can say that angle 6 is equal to 180 degree minus angle 5. Right?
Yes.
Okay. Now here I can say, now because angle A is already equal to angle 5, I have shown it, right? Here we have shown. Angle A is equal to angle B, we have already proved. Clear? So here I can write, so angle 6 is 180 degree minus angle A. This already proved that angle 5 is equal to angle A in previous part. From here also, like, don't call it 1, you can bring it into this form, 180 degree minus angle A. Then you can call it 1. Why? Because RHS now is same for both. This is equation 1 and this is equation 2. Isn't it?
Yes, ma'am.
So from 1 and 2, you can say that angle D is equal to angle 6. And angle 6 is actually angle C, right? So angle D is equal to angle C. Proved. Why I'm writing 6 here? Because you might get confused that this complete should be angle C, isn't it? Yeah,
Yeah, ma'am.
that is why. Why not? Why this complete is not angle C? Because actually this is not the part of the figure, isn't it? This is the basically the construction we have done. So that is why only this much is your angle C. Is that clear?
Yes, ma'am.
I'm just drawing it like this, but basically this does not exist. Is that clear? This
Okay.
part of the figure basically does not exist. It's the construction we have done so that we can use some theorems. We can bring in some relations. So that is why only this much part is your angle C.
Okay, ma'am.
Okay, so one more. Third part is also there in this question. Let's do that also quickly. So in part 3 now again, let me draw it like this. So A, B, and this was your E, C, and D. Now you have to show, so to show that triangle ABC is congruent to triangle BAD. Right. So where is ABC? That means you have to join it, right? ABC, then you can see. And BAD, that means you have to join it. Is that clear?
Yes, ma'am.
So you take these two triangles. So in triangle ABC and triangle BAD. Now tell me three things for congruency. One side is common. Which side?
Uh, A,
Yeah.
AB.
Yes. So AB is equal to AB, which is common. Sorry, AB. Okay. And also this angle, angle B, I mean this complete angle B is equal to this complete angle A. We have already proved.
Yes.
Yes. So angle A is equal to angle B. This is already proved. And
Angle.
See, this side is given equal, right? AD is equal to BC. This is given that these two sides are equal, right? So we have SAS criteria, two sides and one angle. So by SAS, we can say that triangle ABC is congruent to triangle PAT. Oh, there's a fourth part also. Let me just continue here. So in part 4, you have to show that AC is equal to BD. So from CPCT, you can say that, right? Because the triangles are already congruent. So from CPCT, we can say AC is equal to BD. Is congruent to triangle BAD. We have just proved. So by CPCT, we can say that ABD, sorry, ABC, okay, fine. So we can say AC is equal to BD. Is that clear?
Yes, ma'am.
Okay, so this completes exercise 8.1. Now exercise 8.2 we will be doing in the next class. So we will study a new theorem which is called the midpoint theorem, which is an important theorem. So only 2 exercises are there in this chapter, right? See, actually these type of chapters takes time, triangle, quadrilateral, because every question is different in itself. Okay, then let's end the class today. In the next class, we will see. Okay, Jocelyn?
Okay, ma'am.
We will do a small